So here's video number 9 in a series of 9 to help you with the number patterns question in the exam. And I've decided to make it a grand finale horror show of a number pattern with a fraction with different things going on in the numerator and the denominator. So first of all, I'm going to look at the numerator, the top of the fraction, and I can see it's going 3, 7, 11, 15. So it's going up by 4 every time. So if we just think about that, something going up by 4 every time, that gives you a big clue that there's something to do with 4n in it. Now 4n is just 4 times 1, 4 times 2, 4 times 3, 4 times 4. So 4, 8, 12, 16. The numbers in the denominator are actually just 1 less than that every time. So 4n minus 1 gives us 3, 7, 11, 15, which are our denominators. So we've kind of got a rule for the denominator. Let's think about the numerator. So the numerator is going 5, then 10, and then 20. So hopefully you can spot that that's a geometric sequence by now. So it's going 5, 5 times 2, and then that times another 2. So 5 times 2 squared is 20. And that times another 2, 5 times 2 cubed, gives you 40. So generally speaking, they're all 5 times 2 to the power of something. So when n equals 4, it's 5 times 2 to the 3. When n equals 100, it would be 5 times 2 to the power of 99. And generally, they're all 5 times 2 to the power of n minus 1. And a geometric sequence is always the common, or the first term, 5 in this time, multiplied by the common ratio, 2 in this case, to the power of n minus 1. Okay, so 5 times 2 to the power of n minus 1 gives you the denominators. And in fact, that's even true for the first one, because 5 times 2 to the power of 1 minus 1 is 5 to the power of 0 times 2 to the power of 0, which is 5 times 1. So that is completely consistent. But it means that we've managed to get ourselves a rule for the numerator, which is an arithmetic sequence, 4n minus 1. A rule for the denominator, which is a geometric sequence, 5 times 2 to the power of n minus 1. So we've just got to combine both of those to get our rule for the whole thing. So algebraic rule D equals, so our rule for the top was 4n minus 1. Our rule for the bottom was 5 times 2 to the power of n minus 1. So make those into one big fraction. That's our algebraic rule. I've never seen this one, or I've never seen one this hard in the exam, by the way. Or let's just predict the remaining terms in the table. So if we're expecting the numerators to go up by 4 every time, then we want them to go 19, 23, 27, 31. If I can just get this pen to work for a minute. 31. And then we're expecting the denominators to double every time. So 10, 20, 40, 80, 160, 320, 640. So that's what we're expecting for this. Some patterns in words. So one for the numerator, one for the denominator would be a good idea. So the numerators, the numerator of, it's called D this time, increases by 2 every time, whereas the denominator of D, hopefully your handwriting is better than mine, doubles each time. So that's 2 good patterns in words. Okay, so testing and verifying. When n equals 3, my rule says D equals 4 times 3 minus 1 over 5 times 2 to the power of 3 minus 1, which is 12 minus 1 over 5 times 4, which is 11 over 20. And oh, that matches the value in the table. That was lucky. So this matches the value in the table. Don't forget to make that comparison. It's very often worth a mark, and it's a silly mark to lose. And then verifying is just doing the same, but further up the table for the values where you had to fill in a prediction yourself. So when n equals 7, my rule says D equals 4 times 7 minus 1 over 5 times 2 to the power of 7 minus 1, which is 28 minus 1 over 5 times 2 to the power of 6, 2, 4, 8, 16, 32, 64 equals 27 over 320. Now, in an exam situation, I would be trying to do this a little more tidily, but obviously it's a little bit of a payoff between banging out the marks as quickly as you can versus clear communication. Okay, so when n equals 7, my rule says that D should be 27 over 320, and that matches my prediction. So this matches the prediction in the table, and then with that good clear comment, we should be good for most of the marks in a relatively short time.